Welcome back. In this video, we'll write the first part of quicksort. Just like with merge sort, we implemented the merge helper first. We're going to do the same thing here. You might hear this called partition or pivot. It does the same thing. So we're going to write a function that, given an array, it designates an element as the pivot point, and it should rearrange the elements in the array. So this is basically what I already said, got ahead of myself. And ahead of the slides, surprise, surprise, all values less than the pivot are moved to the left, and all values greater than the pivot are moved to the right. But the order on either side doesn't matter. It just needs to be less than the pivot and greater than the pivot on the right side. But inside the left and right, it doesn't matter what order they're in. So the other really important thing is that this helper should do it in place. So it should not make a new array. And it should return the index of the pivot. So it returns the index. It does everything in place, so don't make a new array to do it. So the first thing to discuss, picking a pivot is actually an important decision. The runtime of quicksort can change depending on where you pick the pivot from. Ideally, it should be chosen so that it's the median value in the data set, if that makes sense. If we could perfectly get it, we would pick the middle value of our sorted data so that the left and right sides would be equal. But that's not very easy to do if we don't know what the data itself is and how it's ordered. That's the whole point. We're trying to order it. So there are other strategies. You pick the first element or the last one or the middle or a random element. For simplicity's sake, in this video, we're just going to always choose the pivot to be the first element. That does actually have some consequences with as far as big O that we'll talk about later, but we're going to just pick the first element to make it simple. So here's how it could work. If this is our array and we call our pivot function of that array, it should return index of 4. So notice it doesn't return the array, but if we look at the array, it's been changed. Any of these configurations are valid. So what it does is it picks the first element and chooses that as the pivot, so 5. And now it needs to rearrange the array so that 5 is in the correct spot where every number to the left is less than 5. So if we look at all these examples that could be the value of array, it doesn't matter the order. If we have 2, then 1, then 4, then 3, or 1, then 4, then 3, then 2, and so on, as long as we have 1, 2, 3, and 4 on this side. And then on the other side, we have 6, 7, 8 in some order. Now, this isn't all the possible options. I just didn't want to go and list every single possible combination out, but it's important to note, it doesn't matter for our code what we actually have on the left side, it matters what we have. It doesn't matter exactly the order that it's in on that side. So these are all acceptable. All that matters is that 5 is in the correct spot, and we return the index, which is 4. 0, 1, 2, 3, 4. So this is basically saying, in the final sorted array, if you kept doing this on the left and the right over and over and over, 5 is in its final position. This is where it's going to be once you sort the data. Okay, so here's the pseudocode. Here's one version of it at least. So write a function, call it pivot or partition, and it accepts 3 arguments: an array, a start index, and an end index. And I would have the start default to 0 and the end default to array length -1. Then we're just going to pick the pivot from the start of the array. Remember, and we could change this to be from the middle or the end or a random place, but for simplicity's sake, we're picking from the very beginning, and then store the current pivot index in a variable. So this is going to keep track of where we're going to swap that pivot to at the very end. So I'm going to walk through on the next, in just a second, on visual algo and show you what I mean. But we're going to loop through the array from the start until the end. And if the pivot is greater than the element that we're looking at, we're going to increment that pivot index variable from up here and then swap the current element with the element at the pivot index. So, it's a nightmare trying to just read this pseudocode, but it will make sense once I show you an example. And then at the very end, we swap the pivot that we started with the pivot index. And then we return the pivot index. So rather than just talking about text, let's look at it. So at the very beginning, we're going to pick the first element to be our pivot. We start at 28. Then what we do is loop through every other element, and we compare 28 to 41 in this first case. 41 is greater, so we actually don't do anything. But then we get to 4. 28 is greater than 4, so we know that we need to have 4 on the left side of 28. And we're just going to keep a mental note. We're going to have a variable called pivot index, and that's going to keep track of how many things are less than 28 so that we can then swap 28 at the very end to the correct spot. So we move 4 over, And then we have this pivot index that currently is going to be equal to index of 1. So if there was nothing, ignore everything on the other side of the array. If there was nothing else, we know that 28 needs to be in this position at the end, so that 4 can be less than. But if we keep going, 11 is also less than 28. So we're going to swap that with 41, and now increment the pivot index by 1. So now we know, okay, there are 2 things less than 28. Go again. Oops, didn't click it. Here we go. 16, that's less. So we swap. And now we know there are 3 things less than. Again, we swap. There are 4 variables. There are 4 pieces of data in this array, 4 elements less than our pivot. Nope. Okay, here's our 5th one. We swap. We go again and again and again. And here's our 6th element that is less than 28. So we swap. Now we've hit the end and we have this pivot index variable, this mental note I mentioned, and it's now equal to 6 because every time we found an element less than 28, we added 1 to it. So we have 1, 2, 3, 4, 5, 6. This tells us we need to swap the element at index of 6 with our pivot, which was at the beginning. And if we do that, there we go. Now we're done. All we have to do is return this index. So everything on the left is less than, everything on the right is greater than. The pseudocode on its own isn't all that helpful, but if you look at this side by side with something like this, where you step through it, I think it can help. So go ahead and implement this if you'd like to. Again, it's not all that easy, but give it a shot. If you want to stick around, I'll do one more example walkthrough, but I know that it can get boring. If you understand it all and you're ready to go, or you're just bored, go ahead and skip this. But I'll put it here for extra practice. New data. At the very beginning, we pick our pivot point at just the first thing, 26. Now we compare it to every other element. Now 23 is less than 26, so we're going to keep track of that. We need to have, we have that counter, pivot index, and we know at the very end, at least, we're going to have to swap 26 to index of 1. We get to 27, that's greater than, so we don't do anything. That's greater than again. Now we get to 17, which is less than. So what we do is we swap with 27 in this case, and then we're going to increment our pivot index by 1. So now we know there are 2 things less than 26, so we need to swap at the end, so 26 is here, where 17 currently is. We go through again, that's greater than, greater than, greater than, greater than. Finally, we get to 1, which is less than, and we swap with 44. And now we increment pivot index by 1 again, so now it's at 3. So at the end of our code, we're going to swap the pivot at index of 0 with the pivot index, which is 3, 0, 1, 2, 3. So we swap these 2 things, and voila, now we have the left side correctly partitioned and the right side. So 26 is at the correct spot. And our code should return index of 3, which is saying that the correct spot for 26 in this array is index of 3.